What'd you figure out? Okay. Okay, so I am recording, so let's get through a couple problems. So what is step one with these problems? Yeah, we got to swap them out. So we're going to switch our variables. So are we doing number 3, by the way? Is that correct? Okay, so number 3 starts out as y equals the natural log of x. And when we do our first step, we're going to swap it to say x equals the natural log of y. Now, this problem is crazy hard until you remember what a natural log is. And what is a natural log?
Log base 10.
Log base e. Yeah, remember that a default log log is base 10, and ln natural log is a log with a base of e. And so if we, I'm going to write it that way, just so what I'm saying makes sense. So this is x equals log base e of y. And then from here, it honestly doesn't take long. It kind of takes care of itself. What's the step after this?
Water cycle.
Yeah, this is where we do the water cycle conversion. And the thing that I think will help you a lot is if you just remember the terms that the big one is this is called a base. The thing I just circled in red is called a base, and it will also be the base of your exponential. That always helped me to remember. And then you can also remember that the argument of the log, that's the thing with the arrow pointing at it, that's the thing that gets its own side. So the converted version of this is y equals e to the power of x, like that. And that's it. So, I mean, that's number 3. There's not a lot of meat on that bone, but there you go. So that was intended to be, I think, the third example. And as I said, I blew past it in the notes and forgot. Yep.
Can we do number 9?
Sure, we can. Yeah. So number 9 has us doing, I'm just gonna switch the variables. I remember that from Thursday. So I'm just gonna switch them, and we're gonna have x equals log base 4 of y to the power of 5. Anyone know what to do first?
To get rid of the power of 5, right?
Nothing cracked in the wall.
No. I see why you'd want to do that, but no. Yeah. So what we want to do is get in right away and create the conversion. So, and we're ready to do that. I can tell you this, that later on in the assignment, I think you're going to see problems where this 5 is in the wrong place. Like if the 5 had been down here where this arrow is pointing to, then we'd have a problem because we'd have to move it actually up as an exponent to get it out of the way. But what we have here actually is exactly what we want, and that is just a nice, clean, single package logarithm ready to go. So at this point, we're going to hit it with the cycle and say 4 to the power of x equals this. But I like to write it in the other order. So I'm going to take this thing and put it by itself and say y to the 5th power, you are equal to 4 to the power of x. So far, so good?
Wouldn't you raise both sides by power 1/5?
Yes, you would. And so at this point, it's time then to get rid of the power of 5, now that we have it kind of converted over into the land of exponentials. And so in a case like this, we would say, and I'll show you my work here. Like Cooper said, I'm raising each side to the power of 1/5. Because what that accomplishes is these two numbers in this green egg, they cancel each other out. It's the kind of the whole idea what we're trying to get to happen here. Get y by itself. So we have y equals 4 to the power of what? And x over 5 is just fine. I'm just going to write it as 1/5 of x, again, just to kind of get that transformation to be separated so that when we get to graphing these, we can see that as a horizontal stretch of times 5. Having it detached on its own just helps later. So, does that make any sense at all? I want to pick a couple more. I don't want to do the whole worksheet with you. That seems counterproductive, but sure. How about you pick one? Sure. So 13 says that x is equal to 2 to the power of y plus 10. What do we do first? For sure. What you come to know with these is that you either want to get the log by itself or get the power by itself. That's really the key first move. And in this case, that 10 is way out of place. So we're going to rewrite it as 2 to the y is equal to x minus 10. And so, and you can switch sides, it's this, like we're new at this math thing. So left and right means nothing. Do write it however you want. Yeah, so now it's time to convert it from an exponential to a log, right? So we're going to say that log base what?
2.
2. And I can't stress enough to you that again and again and again, this thing that I'm circling in red, when you have like x squared, x is called the base and 2 is called the exponent. So the base of an exponential becomes the base of the logarithm, which is really convenient when you're ready to understand that. So we have log base 2 of what? Of x minus 10 equals, and just like that, it's done. Just one step, never even saw it coming, and poof, you got y by itself, it's done. So the idea behind this is that the original problem up here on the board said that y equals 2 to the power of x plus 10. Where I'm going with this is that eventually this thing in the yellow egg, we will graph. This thing in the yellow egg, we will graph, and we will see something about them that will show us that they're inverses of each other. But we haven't even learned how to graph logs yet, so we're a ways away. We got a little work to do.
We do 14 now.
Yep. Sure. Yeah, I might just have to, maybe we'll just do a bunch of these together and then I'll make you another assignment where you don't, because if I do them with you, what I see is a lot of people just going like this. And you're not learning if you're doing that. Like, I understand you're just doing your job, but really when we're learning is when we're doing them by ourselves. So I don't mind helping, but we're probably going to need another assignment where you leave me out of it. So we have y equals 3 to the power of x over 2. And I just, again and again and again, will tell you that thing in the red egg is called a power. It needs to be gotten by itself. The water cycle won't work. This conversion won't work. Yeah, and I forgot to switch my variables. So let me do that. But you're right, Emma, we're going to multiply by 2. So let me get this switch done first. So x equals 3 to the power of y over 2. And then, yes, exactly. Perfect. We're going to multiply both sides by 2 like this. And then the 2's are going to cancel each other out. And we're going to go poof, presto. And we're right where we want to be because now we have the 3y or 3 to the power of y all by itself. And that's equal to 2x. And now that the power is by itself, we're ready to hit it with the conversion. It's going to be log with a base of what? 3. The base of the power will be the base of the log. Log base 3 of what? Equals, and there's your inverse.
And
Done.
when it's 6, well, instead of x equals 3y, but divided by 2, if it's x equals 3, and then 1/2 y, then it becomes x. Right? Move on.
I'm sorry, I don't know. I really, it wasn't me not trying to listen. I just have no idea what you said. Where are you?
I'm expecting that, like 16.
Oh, you're on a different problem.
Yeah.
Oh.
I know, but, like, I got those two. Sorry.
Oh. Do you want to go over 16? What you're saying?
I'm sorry. No. I got it.
Nice.
No.
That was a great talk. Where are we at? We good? Okay. Well, I'm going to pause this, and then if you want to go over more, like I said, I don't mind. I'll just make another assignment because really, you just need to practice. But I can guide you through some more of these if you need. To you. So I'm going to go ahead and swap the variables. We're going to have x equals log of 2y. So this needs to get hit with the conversion. This is number 10, by the way. So what's the conversion going to look like?
Okay, in my notes, we have an example like that, and I just have it go through like that, to like 2y.
So the thing that you have to remember about logs is there are two types of logs that have invisible bases. One of them is a natural log that is actually a log with a very real base of e. It's there, we just don't write it. Another log that has an invisible base is what we call a common log. And this is a log that by default has a base of 10. When you see a logarithm spelled log, not ln, but log, it is a base 10 log, and you're welcome to write it in. So that's where something like that comes from, is that this is actually an invisible base log. And we call it a common log because if you think about it, our entire number system is founded on tens and powers of tens, right? And so that's why that's the most commonly used type of log, base 10. Right from here, yes. Like it's done because this is a log and it's by itself. If there were something else after the log, like if there were like a +4, I would subtract that 4 away, right? But there's not. There's no extra junk, so we're just ready to hit it. So what's it going to look like when we cycle it up and out?
10 to the power of x equals 2y.
Just like that. This to the this equals this, like over and over again. So I'm going to write it out as 2y equals 10 to the power of x.
And then we divide by 2.
And then we're done. So the answer is that the inverse function y is equal to 10 to the power of x divided by 2.
So you don't simple.
You can't. Do you thinking about reducing the 10 and the 2? No, this 10 is bound up in something that the order of operations says you leave me alone, right? 10 to the x is like, whoa, 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 you don't get to whittle me down. Got it? Okay. So this is, so I'm going to swap my variables and I'm going to subtract the 8 because I don't want to waste time. So I'm going to have the x minus 8 is equal to the log with a base of 3. And it's the argument of the log is -4y. So the only way to free that y from the prison that is that is to water cycle it up and convert it to exponential. And it's ready to go because we got rid of the hanger-on or the +8 that was at the back. So when we water cycle this up, we're going to do 3 to the power of this equals this. So we're going to say that -4y is then equal to 3 to the power of x minus 8. You okay? Okay. And then at this point now, we're due to some simple algebra left to do. We have to divide both sides by -4. And that's it. So we're going to have y equals 3 to the power of x minus 8, all divided by -4. Yep,
Not a 16.
16 it is.
How many things are more harder than that?
This is not simple. So, I mean, I think, and sometimes in math, you're right, people make things hard, but this can be a bit intimidating. So you're fine. So when I swap the variables, it says x equals 6 to the power of y over 2. So because the exponent or the power is by itself, this is ready just to convert straight over. So it's going to go into a log with a base of what?
Oh,
Bless you.
I was, yes.
Log base 6 of x.
No, there's a 2. Y divided by 6.
Good.
You grade both sides to 2y.
Yes. So we multiply both sides by 2, like this. And so we wind up with y equals. Now I'm gonna show a step that normally I will skip, but I'm not going to skip it this time. It's going to be 2 times the log with a base of 6. Like this. The answer actually should be y equals log base 6 of x squared. And the reason, remember, is that this 2 is a flyer. Because, and we're allowed to do that because it's the coefficient of a logarithm. So under normal circumstances, such black magic is frowned upon. But when we're working with logs, numbers in the front fly upstairs and vice versa. They can also fly back down. Got it?
See if I can make it.
Hello.
Naturally.
Mm-mm. Are you done with every problem?
Yeah.
Front and back? It's impressive. Yeah, hang on a second. Let me.
I think I need to rerun through some of these because
So I'm going to go ahead and swap them. So we're going to have X. This one, this is interesting. You can kind of go both ways on this. So I'm not going to skip any steps here. So we have X equals 8 times log base 2 of X minus 7. I mean, one thing that we have to agree on is what?
You gotta divide that.
Right. And I mean, honestly, you could even move the 8 up if you wanted to, just for the record, but we have to tend to the 8. The 8 either has to fly up and become a power on the X minus 7, or it has to divide by the X. I'm going to go ahead and just keep it simple and divide by 8. So we're going to get X over 8 equals log base 2 of, oh, I forgot to put a Y here. That's my bad. And once you get that log by itself, which we have now done, what's it time to do? Convert it over, you bet. So in the pattern of this is just repetitive as all get out. It's going to be this to the power of this equals this, like over and over again. So what's that going to say?
Why?
Yeah. And then we're going to add 7 to both sides. I mean, once you survive that big step, then it's really fundamental stuff from there. Just add 8 or add 7 and you're done. So you get Y equals 2 to the power of X over 8 plus 7. And I don't know if you're interested in this or not, but I'm going to show you anyways. I want to show you something I said earlier. You could alternatively have taken this 8 and put it up here, and you could have rewritten this as X equals log base 2 of Y minus 7 to the power of 8. And I don't know if you'll find this interesting or not, but by getting that 8 up in that way, instead of dividing by him, at least we've still got the log by itself. So we could say that we have 2 to the power of X is equal to Y minus 7 to the 8th power. And I don't know if you buy it or not, but like it's all going to come out on the wash. You would agree that we want to take
that's like
both of those and raise them to the power of 1/8. And so look at what we wind up with. It's actually kind of cool. We wind up with 2 to the power of X divided by 8. And look at, we're right back where we started.
Okay.
The moral of the story is that 8 just had to go early. How you choose to deal with it is whichever one you like better.
They're just little things. Like this.
Yeah.
I always moved it up. They should be on parentheses.
So I just forget to switch them. X equals -2 times the log base 6 of Y. So I have to ask you again, like, what's your preference? Would you rather you like that first way we did it? Okay, that's fine. And then it's time to do our thing, huh?
Yep.
So you should have Y squared equals 6, bless you, to the power of, you could put negative X over 2 or X over -2, however you want to say that, it doesn't matter. And now how are we going to get Y by itself? Don't multiply. I think you're saying the wrong thing. You're saying the right thing in the wrong way. Raise to the power of a half, right? Yeah. So if we raise both sides of the equation to the power of 1/2, then we accomplish our mission and we get Y equals 6 to the power of negative X over 4. Is that what you got? Nice.
Thank you.
You're very welcome. You guys all done? Feel good?
Probably don't put a wrong triangle.
Yeah.